Okay, so this quiz you are looking at was for 2025 March, 2025 March last year. So it was written, that's quiz one for mathematics for social sciences. Okay, so I'm just going to walk you through the solution sets. So question one, if we read through here, it is saying let A, question one is here, let A, let me change the color to black or maybe red. Okay, says let A B, C and D. I mean A, B and C, B subset of the universal set E. Okay, simplify B complement union A complement intersection B. Okay, so we are simplifying that as follows. So when you look at this is what we want to simplify. So here you are using distributive law, where you distribute this to this, also distribute this to this. I mean to B. Distribute B union, B complement union B. So you are going to get this result. Then intersect everything you get. Then you can also reverse this. So when you distribute these two, you get this result for the first distribution, this result for the second distribution. Okay, so once you do that, what remains next is just to simplify those. Okay, so when I look at B complement union A complement, intersection B complement union B complement, I can't further simplify this, but I can further simplify this because I know that B complement union B is just the universal set because you are taking what is outside B and what is inside B. So it is going to give you a universal set, which means now intersecting this set I wouldn't simplify with the set that I have simplified. Now, when we are intersecting two sets, you get the smallest set if they are intersecting, because for the sets to intersect, one has to be the subset of the other. So you see that this set is actually the subset of the universal set. I'll give an illustration. So the universal set will look like this. This is the universal set. Then A, maybe have A here, B here. Okay, so I have A here, B here. So B complement is what is outside here, and union A complement, meaning you are talking about something that is outside these two sets. Now, when you intersect that with everything that is in this set, meaning everything there, you see that they will only intersect outside A and B, which is actually B complement union A complement. So that is how we have got this answer here. Next question says, given A is in B and A intersection B intersection C is non-zero or is non-empty, we shade the region A intersection B complement union A union B. So now here is the one point that we have to be clear about it. In fact, I didn't represent this very well because you take note that A is in B. So if A is in B, then we have something like this. So you can have your C here. So you say this is your B, this is your A, then this is your C. Okay. So now if you want to shade this set A intersection B complement, A intersection B complement is actually an empty set because B complement is what is outside B here. B complement is what is outside B. Now, where that intersect A, it is not existing because A is inside B. So A intersect B complement is an empty set. Is an empty set. Now we want to find the union of that with A union B, meaning that the only answer you're going to get is A union B. So A union B is equal to B. Therefore, you are shading this region. Since you are saying this is an empty set. So when you find the union with an empty set, you are saying union. So that implies that notation will not be fine. So that will imply that, let me erase here. So that will imply that A intersect B complement union, excuse my writing, union A union B. A union B. Okay. Here we are saying that this is an empty set. Is an empty set. So when you combine an empty set with A and B, you get yourself A union B as your answer. Now see that A union B is just equal to B because A is in B. I think my answer was not nice there. So on your diagram, you are going to shade the following. Okay, you're going to shade this. You're going to shade this region B, shade B. So you are shading B. Yeah, not outside B. Should excuse me. So that will be the answer that we get for this one. Then, well, okay, so that will be the answer. Then we come to the next question, which says, that is question 1b, let A be from -9 to 1 and B from -4 to 5 be an interval of real numbers. Find the real interval, show your work by shading real number lines. Okay, so I've done the work here. Okay, I've done the work from here where I said A intersection B will mean to intersect these two, this intersection, this. So if you are not using shadings, you just check these two sets, this and this. And when you are intersecting, you check the beginning of this set and the beginning of this set. If you are intersecting, you pick the biggest of these beginnings between -9 and -4. Which one is big? -4 is big because you want to pick a piece that is inside. So you pick the piece that starts with -2, -4. Therefore, we're picking that one. That's how I picked this part. Then the other one, the end point, now you're considering 5 and 1. For the right end point, you pick the smaller. So between 1 and 5, which one is smaller? 1. Therefore, I'm picking this piece. So joining them together gives out this as an intersection. So showing it on the number line, draw the real line. Draw the real line as I have drawn here. Okay. Then you draw your A from there to there. Draw your B from there to there. Where they collide, these two, that is the intersection. That is here. So that is from -4 to 1, as I have indicated here. So that will be our solution set. Okay. So the next question, hope that is clear. So you mark yourself there. You mark yourself there. You'll be proud of yourself and say, okay, I've got that right. All right. So the next question is saying, it's the same question again. We are simplifying and sketching all that. So if the question is saying we use a number line, therefore you draw a real line, which is this one. Okay. You have -9 here, -4 here, 0 here, 1 here, 5 here. Then you check your set. Your set is A complement union B. So for you to find A complement, you have first to figure out what A is. A is running from -1 to 9, excuse me, from -1 to 9 there up to there, which means that A complement will run from here going all the way to this side. This is A complement here. Then the other piece of A complement will run from there going to all the way this side. Okay, so you be careful for picking A complement because you know A is starting from -9 to 1, where -9 is not included but 1 is included. So you better know how to, if 1 was included in A, then it should not be included in A complement. If -9 is included in A, then it should not be included in A complement. So A complement here is what we are interested in because that is what is appearing there. Then the other set that you have is B. So this is B, excuse me. Okay, so B is here, lying from there up to there. So when we combine these, B is lying from here up to here. We are combining with the A complement which lies there. Then the other A complement lies here going this side. So when we combine these two pieces, the only piece that we are going to leave out is between -9 and -4. Therefore, our solution set, we are unionizing this piece that goes to the left up to -9 and this piece that goes to the right from -4, which is basically the answer I put there. Okay, the next question. The next question is question 2. So question 2 is saying simplify the root of 200 plus the root of 18 minus the root of 72. So here is the answer. Okay, so we have root of 200 here plus the root of 18 minus the root of 72. So how do you simplify sets? So the easiest way to simplify sets, you look at the numbers that are inside there. Then you find their biggest perfect square factors. I've highlighted that here. So what is the highest perfect square of 200? I said it's 100. So you partition that number in 200 times 2. Then what is the highest perfect square of 18? That is 9. And how many 9s are in 18? That is 2. So that is 2 multiplied by 9, or 9 multiplied by 2. What is the highest perfect square of 72? That is 36. How many 36 are in 72? There are 2. So you write that and distribute the square root according to the properties of surds. So you have this, this, this. Then those perfect squares you can simplify. So perfect squares can be simplified. Root of 100 is 10. Here, root of 9 is 3. Root of 36 is 6. Then do addition and subtraction accordingly. So I know that 10 root 2 plus 3 root 2, that is 13 root 2. Then I subtract this, which is this here, minus root 2, minus 6 root 2 from 13 root 2. That gives me 7 root 2 as a required answer. So the key component here is how to simplify the surds. If you get that right, then we are together right. This one says we have to rationalize, or we have to write the answer in the form a plus b root 5. Okay, so a plus b root 5. So that should be easy because we just have to multiply by the conjugate of the denominator, multiply by the conjugate of the denominator. Okay, the conjugate of the denominator here is this one. So the conjugate, it doesn't matter, could be this one, I'll put it clear here, or this one. If you do any one of the two, you will get the same answer. So I used this one and multiplied through. Therefore, the numerator here multiplied by the numerator here. That is giving you this part here. Then the denominator multiplied by the denominator. That is giving you here this. Okay. Then I know that the denominator is just the difference of two squares. So I'm just saying square of root 5 minus square of -1. I mean square of 1. Then the numerator you can expand 3 times root 5, you get yourself 3 root 5. 3 times, or you can say root 5 times minus 2 root 5, you get yourself minus 2 times 5 because the root will go away. Then the other thing is, okay, so yeah, you distribute like that. Then add the like terms and simplify those stuffs, then you get your answer like this. So if you want, your answer can be 7 over 4 plus, because that format they want you to write it in is looking like this: over 4 square root 5. So that is the arrangement, but nevertheless, it's the same thing. It's the same thing. So in the next, I think I'll continue from there. I have something coming up. I have a class. So I'll end here, and best regards. So see you next time. Okay. All right. We'll see you next time.